Here's an AI app I've been working on where you can input a prompt like create a sign up form in React. And then the job of this app is to generate only the code needed. Here's the code for a sign up form, but maybe instead of using an email, I want to actually change this to a username. And then maybe instead of React, let's convert this to HTMX. And it actually knows how to display the HTML over here. And then one of my favorite features is that you can grab a screenshot of UI and throw it into the app here and say use HTML and Tailwind, and it will generate a version of that UI that you can iterate on. And I'll make a full video on this when it's ready for normal use, so make sure you're subscribed so you don't miss that video. But in this video, I want to show you how to use GPT-4 and GPT-4 Vision to create a simplified version of this application using Next.js. And the simplified version looks like this, where you can input an image. I can tell it to create this with React, and it should generate the code for that screenshot, which just happened to be a shot of my YouTube profile. We'll also be able to adjust this, so I could say convert this to Swift UI, for example. So we'll be able to use images and text to prompt the AI to write new code or adjust code. Then all of this is going to get stored in a database so that we get a unique link for each thing where we can actually share these if we want to. And we'll go over absolutely everything to get this working, because the current starter that I have contains pretty much nothing except the bare bones UI needed. So I have really nothing going on here. I do have this input bar at the bottom that will accept both images and text. And if I input something in here, then it will console log it to the terminal, but it doesn't do anything else. So we need to implement absolutely everything to get this working. So if we look at the code here, I have this page that loads a client component where I have that input box at the bottom here, and I'm just console logging out the values that are put in. So the first thing I really want to do is submit this data, whatever I type in, to the server, and then send that to OpenAI so it can actually generate an AI response for us. So the first thing we're going to do in the app directory here is make an API route. And inside that, let's call this message. And we'll make a route in here. And this is going to be for a post request. So I'll just export async function post, and this will accept a request object and return a response. So then in my client component, I should just be able to make a fetch request here to /API/message. And this will be a post request. We'll JSON stringify the value. We're going to ignore the file that can be input right now. We'll come back to that later. So whatever I have in my text field will be sent up. I'm actually going to call this content. This should also have the header content type application JSON. Let's await this. And I need to make this an async function, and then that's all I'm going to do here. But on the server, I'm going to accept that content coming from rec. So let's say content equals await rec JSON. Perfect. Okay, so when I send a post request, I can send the text up as content, and then on the server I can grab that content. We'll need to send that to OpenAI and then send the response back down to the client. But now let's just check everything is working by doing a quick console log on the server. If we go back over to the browser here and I input a message, when I hit enter, it should send that to the server. And then in the server logs, we should be able to see that content there. So whatever we send from the client will be in this variable. We now need to send it to OpenAI. To do that, I'm going to open up the OpenAI docs. So we'll go to API docs here, and then we're going to scroll down to libraries and then go to the Node.js library. And then it gives us a little snippet here. So I'm going to copy that and then we'll talk about it a little bit. So that's going to go in here. This is going to go all the way up at the top. Actually, I'm going to pull this out of the function in case we want to use it in multiple routes. Here we're setting up the OpenAI object, which we need an OpenAI key for. So I'm just going to throw this into my environment variables file for now. We'll have to generate one of those in a second. And then here we're creating a chat completion object. So this is how we actually send the data to OpenAI and get a response from OpenAI. Instead of putting in this test message, I'm going to put in my message coming from the client. Instead of using GPT 3.5 Turbo, we want to use, let's see, if we go up to models here, we're going to use GPT-4, and there's two different versions of GPT-4 Turbo. There's the normal one and there's the one with Vision. So we can use this one if we're just using GPT-4 Turbo, but we're going to need the Vision one for this app. So let's copy this model, and notice that these are both new and not production ready yet. So make sure you check back here at some point to make sure you're getting the latest versions of these models. But that's good right now. We're going to paste that into the model. And then we need to generate this Open API key. So for that, I'm going to go to API keys, and you'll need to sign up for an account before you can do this, but I'm going to create a new secret key. I'll call this code GPT. That's the app I'm building. Create a secret, and then you can copy this secret from here, hit done, and go and paste that in your environment variables. Perfect. So now this should be ready. We could probably run this and log out the chat completion. However, this is going to get all of the response back from GPT as one big block of text rather than streaming it in. So if we run it like this, it's going to take a while for us to get the response. And what we really want is that nice streaming thing that happens when we use ChatGPT, where as soon as there is a single word or a single token that we can see, it streams into us and we see it incrementally get built up. So we want to mark this as stream true, and that means we actually get a stream object here that we need to stream back down to our own client. So I'm going to go over to the Next.js docs right here, and I'm going to search for streaming in the route handlers. And if we look here, we can see that if you create a readable stream, you can use that to return a streaming response from your route handler and have your client receive the response in chunks. And this is an example of how to set this up with a readable stream. But if we go and check the Vercel AI docs, we need the SDK docs. I think that's over here. And they have a section on back pressure and cancellation. And this document explains pretty well how you would create a readable stream and stream down your response to the client. But it also kind of mentions the dangers of implementing this on your own. And Vercel have actually given us a nice way of handling this using their AI library. So instead of having to write a whole bunch of that code, actually, if we go back to the other docs here, we can see. So instead of having to write custom code like this, we can use their AI library, which allows us to just stream down a response super easily. So I'm going to copy this into here. And I'll copy these lines as well. So let's replace that response with their response. This is going to come from the chat completion. I'm not going to console log that out anymore. This is all we really need to send that response or stream that response back to our client. And then I'll also need to install add the AI library. So now if I make a post request to the server, I should get a streaming response back down to the client, which means that the client part of our application, the stuff running in the browser, needs to be able to handle this as a streaming response. So the way we do this is to, well, first we can check if the response is okay. And actually I'm going to invert this. If it's not okay, I'm going to do really bad error handling. I'm going to do alerts for everything for now. I'll fix it at some point. So if it's okay, it's not going to be a JSON response. It's going to be res.body.getReader. This is not going to be awaited. And I guess we should also make sure that there is a body here. So if it's not okay or there is no body, then we'll error. If we do have a body, we can get the reader, which I'll just call reader here. And the way this works is we can call reader.read and await this, and we'll get from this a value or a done, which will tell us that there's no more data left in the response, or we'll just keep getting the values as different chunks from this reader. So we need this to keep going as long as there is still data to be read. So we can wrap this in a while loop that will keep trying to read new chunks from the stream until we're done. And then when we're done, we can break. And I always like curly braces, but I don't like semicolons. So let's create a prettier file and remove those semicolons. Okay. So the value here is binary data, and we need to convert that to text. So I'm going to create a text decoder, and we're going to use this to convert the value to text. Const text equals decoder decode. And then we could console log each chunk as it comes in, but let's actually build up a string here. So let's say our final result is an empty string. Every time we get a new chunk from the server, we can build that up, and then we can console log the final result. So there's kind of a lot going on here. We're going to take some input from the form. We're going to send that over to the server. The server should stream down a response from OpenAI. As that's happening, we're going to grab each chunk right here. We're going to convert each chunk that's coming from OpenAI to text, and we're just going to console log it out right now. So let's go back to the browser, and as long as we have the console open, this should be okay. Let's tell GPT to say hi and see what happens here. So you can see the stream coming in. It's hello, how are you doing today? But here's each chunk that we actually get from the server, which we would be able to display to the user as it's being streamed in rather than having to wait until the end. So let's try this again, but we can create a state variable here. So let's create a variable called assistant response, and I need to import use state from React. Good, I don't need this here. What I'm gonna do, instead of building this up this way, we will set the assistant's response to be, oh no, that's bad naming, current value plus the new text. Okay, so we'll keep building it up in the same way, but we're using state instead of just a normal variable. And then the AI content goes here. So we'll just dump this onto the screen. So now we should be able to see it come in on the screen now. Say hello, let's see what happens. There we go. Hello, how can I help you today? Tell me about yourself. My purpose is to assist. Okay, let's try something else. Write me a poem. That was kind of crappy. Write me a function in TypeScript. Oh, you know what? This is actually getting cut off early because it's not using enough tokens. I wonder what the default settings are for the tokens here. So let's see if we have GPT-4 with Vision. It has a maximum of 4,096 output tokens, but it doesn't tell me. I'm not actually sure how many tokens it's using by default, but it's definitely not a lot. But we can just go to the route and change this so we can set the max tokens to be, and you can set whatever number you want up to 496. So I'm just going to set that to be the maximum, but this could end up costing you a little bit more. It's not super expensive, but you might want to be a bit careful with this. So let's try this again. Write me a TypeScript function. Let's see what happens here. Maybe I need to refresh this. Write me a TS function. Why is nothing happening now? Oh, let's check. So maybe I did something wrong. Nope, everything seems to be fine. Oh, here we go. All right, cool. Yeah, no, it responded. It's good. Sure, here's an example of a TypeScript function, blah, blah, blah. Okay, so you can see that it's trying to write a TypeScript function, but GPT responds with Markdown. We can see the code block here, and currently we're just dumping everything out as plain text. So this isn't ideal. What we really want to do is be able to display whatever GPT gives us. And there's a really simple library called React Markdown, and we can use that really quickly just to get this Markdown displaying nicely. So I'm just going to scroll to one of their examples here. Let's go with this one. So we're going to need React Markdown and React GFM. So let's install those, add that and React Markdown. And then we can copy some of this code over. So we're going to need this and this. Back in my client component, I'll put that in here. So the assistant response is the Markdown. That's good. And then we just need to import the rest of this in up here. So that's these two. Cool. Okay. So that should be enough to get this displaying correctly on the page. There we go. So it is displaying it as Markdown. So I could even say, make me a bulleted list of the in creating a sum function, and it should be rendering the markdown correctly as HTML. There we go. There's the unordered list instead of the markdown content. So it is rendering it to HTML. It just looks kind of crappy for two reasons. It's unstyled HTML. I'm using Tailwind and none of these have Tailwind styles. And the other reason is because the code blocks are also unstyled. So it just looks like a black and white piece of code. So to fix the text issue, we can use Tailwind Prose. I think that's how you pronounce it. Tailwind typography anyway. So really all we need to do is add this Prose class to the div here. So I'm just going to put this in here. And then we also need to make sure that we install typography as a dev dependency. So bun add -d, there we go. We're going to need to add this to the plugins in Tailwind. So I'm going to go to my Tailwind config and throw that in here. And now it should be rendering a little bit nicer. Yeah, okay. It's rendering for light mode and we need it for dark mode. So we can just go back here and say dark prose invert. I think that's all we need. And nope. Oh, actually it might have just got rid of all the text. Okay. Make me a list of things to do today. Let's see. Cool. All right. So that is now coming out a little bit nicer for the markdown content, but we need a plan for making the code look nice. So for that, I'll go back over to the examples because I think they have an example with code. Yeah, it's right here. Okay. So we can use the Prism syntax highlighter. We're going to install this dependency on add React syntax highlighter. And then we're going to take these two lines and all of this code right here. We're going to configure this markdown block. Let's see right here to render the code block using syntax highlighter, which we need to import up here. And it's complaining it doesn't need the rest. It's going to use a dark theme. Okay, so this should be good. Let's go back over and have it generate some code. Write me a TS function. So, okay, I mean, it's generating the code. It's rendering the code. I mean, it doesn't look great. Let's actually just change the theme. So let's go see what themes we have access to. VS Code Dark Plus, that's good enough. Okay, let's see. Does that come out better? It cleared it all. All right, write me a TS function. Okay, all right, that looks fine. That looks normal. Awesome. One more thing. I just want to make sure we wrap lines and wrap long lines, just so if the code goes all the way off the screen, it will just wrap it so we can see it. Now that we have this rendering correctly, I really want it to just only render code. So if I say, make me a sign up form in React and Tailwind, I want this to only give me a code block. I don't want this extra text surrounding it, and I don't want it to give me an explanation after, because GPT can write a lot of text. And for the sake of this application, I don't want any of that. I just want the bare bones code that I can then iterate on. So to get this working correctly, you have to use an initial system prompt or user prompt. I'm going to go back to my route and I'm actually going to create a brand new file here called messages. And I'm going to manage my messages that I send to OpenAI in here. And I'm just going to dump in some pre-written messages because basically I'm just telling this thing to write code and only respond with code. And I've written all of these prompts just to try and get it to write code only and hopefully write good code. So we have these messages. The role is system for the first one, role is user for the second one, and then just a whole bunch of text for these. And what I want to do is put these in as the initial messages every time we send a message to GPT. So I'm going to bring over this array of messages in my route. So I'll say import initial programmer messages from messages. And this is prompt engineering. And I think there's a section up here. There's a bunch of stuff online about prompt engineering. I am not an expert prompt engineer anyway, but I use this to get it to do what I want. So we're going to give this an array. So I'm going to spread this array at the beginning. Okay, so we're just going to load up messages in this array. We only have the most recent message and the initial messages, but this should mean every single time I send a message now, so let's just say, I don't know, a login form, I shouldn't even need to give it much context. It will just only generate code for me, and it will have to pick a language and framework, I suppose. Maybe I should refresh this. It's not doing a good job appending it onto the end. So let's go a login form. And now it's only giving me the code. It chose React as the library. Fine. That's an okay decision. Now it will only give me that code as a response, which is exactly what I want for this application. Now this app is still missing a lot of features, but it is kind of a minimum version of an AI application. There's just one thing that is missing if you're going to deploy this thing to Vercel, and that is you need to make this route an edge function by export const runtime equals edge. And the reason we need to do this is because, let's look right here, the Node and Edge runtimes on Vercel both support streaming, but serverless functions can't stream indefinitely, whereas Edge functions don't have a maximum duration, so Edge functions are much better for streaming LLM responses. And now that we have that set up, you could deploy this application to Vercel, but let's keep adding more features. So the next thing I want to do is make this image feature work, where if I give it an image, it should be able to look at that and generate code based on it. And in my code, in my client component, when I submit my form, I get this file object. And my form here is just a bunch of client-side code that's mainly here for styling, but it is just using a general form input to allow a user to grab a JPEG or a PNG. So when that's selected and it's part of the form submission, we get to this function here and we have a file object. And now what you should really do with this file is upload it somewhere like S3. And I have a whole other video on storing images and files in an S3 bucket. So I suggest you check that out and store it correctly. But for this video, I don't want to go over all those steps. So I'm going to show you another way that isn't really ideal, but will work for small amounts of data. So if we upload it to object storage like S3, we end up getting an image URL from there that we store in our database and we can use to just retrieve the image from the bucket. To send an image to OpenAI, we need an image URL, but if we don't have the image uploaded, what we can do instead is convert the image to a base64 string and use that instead. So I have a function in my utils here that will convert a file to base64. It just takes in a file object and converts that to text. So I'm going to import this right now. Import convert to base64 from my utils. That's lib/utils. And that's from not form. And then we can use this with the file. If there's a file, let's convert that file. Const image URL equals await. And then when we have an image URL, we need to create an array for the content because we're going to have two messages that we send to AI. The first is going to be type image URL, which contains the actual URL of the image or the base64 string of the image. And then the second message we send, type text, and the content is the text value that's coming from our form there. And then we need to run the fetch request, but using this content instead of the value passed in. But since this stays the same pretty much, whether it's a file or no file, I'm going to break this out a little bit. So what I'm going to do is create a new body variable up here that is an empty string, and we can set that equal to the stringified value here. So if there's a file, the body is just going to be that content, else body is going to be exactly what it was before, where we're just passing in the text value. And then we'll send that up to the server. There we go. Okay, so that should be enough to send the image up, and GPT should be able to see it. So I'm going to pass in that screenshot that I have of my YouTube profile, and I'm going to say use HTML. And hopefully, and I've immediately got an error here. So let's check the backend console, and it is saying that it's an invalid format. Content blocks are either text or image URL. Oh, right. Okay. So this isn't content value, it's text value, and this is image URL, but it's not the URL, it's actually an object. Okay, I think I've got this right this time. So that's what the structure looks like. So let's try this again. I'm going to give it the screenshot and say use HTML and no errors. And there it looks like it has generated an HTML page for my YouTube profile. So now we can send it a prompt, we can send it an image, and it's always going to generate us a code block. If you've ever used ChatGPT, you know that there's a way to stop streaming if the AI is creating something you don't like. So create a form. If I don't like this and want to stop it, we currently have no way of telling GPT to stop writing code. We're just kind of sitting here waiting until the end. Let's implement that. So the first thing I'm going to do is create an isLoading state variable that we're going to set to true as soon as we start submitting that, and we'll set that to false when everything is done. And basically, if loading is true, we want to be able to tell GPT to stop streaming. And in my chat input here that I have at the bottom, I've already set this up so it will show a stop button, and I have a function that I can call when that is clicked. So first I have to tell it if it is streaming, then on stop, we're going to handle stop, which should just be a standard function here. So I'm not going to put anything in there for now. I just need that function. But now if I tell it to do something, I will see that the button changed to a little stop button there. Maybe I should say write a function. See, there's a stop button. If I click it, nothing happens, but we need to tell GPT to stop streaming at that point. And the way we do this is just to cancel the network request, and this streaming text response will handle canceling the API request to OpenAI. To cancel a fetch request, we can use an abort controller. So I'm going to create a new abort controller ref, and I'll import use ref for this. And if you need a refresher on use ref or abort controllers with network requests, I have React videos that I'll link to in the description of this one. When the network request is created, this long running one right here, we're going to create a new abort controller, set that to be the current. And then within the network request, we're going to tell it to use the signal from that abort controller to know if we want to cancel that request or not. So if we abort from this controller, the fetch request should just cancel what it's doing. And then if we make it to the very end without it having been canceled, we can set that abort controller ref to be null. And then in handle stop here, if the abort controller is null, we can just do nothing. Otherwise, we are going to call abort. So running this function should stop the network request if it's currently running. And then we would also want to set this to be null. And now this should work to stop the streaming response. So now say make a sign up form, and we get that little stop button here. So if I click this button, it immediately stops streaming. We do also get this uncaught in promise exception, and we get an error here. And the reason for that is when we abort a fetch request, it does throw an error. So now we need to wrap this in a try catch. And I might actually just wrap all of this in a try catch and then handle error handling better a little later on. There we go. That looks fine. So I'm putting all of this in a try catch. And if the error, there we go, .name is abort error. Let's just set this to any type. Then we don't have to worry because we aborted the network request. This isn't actually a real error that we care about. We just continue as normal. But if it is not an abort error, so let's invert this a bit. Again, my bad error handling. Let's alert the user, hey, there was an error. Now, I don't know, do a thing. Let's hit, I need to make bigger ones. Write a function. Got to make these longer. Also, I think we should set the response every time. So every time we call submit, let's just set the response to be an empty string. Okay, let's refresh that. Make a profile page. That's going to be a longer one. All right, so it's writing this. If I click that, we don't get any errors here, and it stops all of that streaming. And then I could start again a login page, and I get to create a brand new one, or I could stop that. That's absolutely fine. But now we can start streaming with text, with images, and we're able to stop the stream whenever we want. And this is already a pretty decent application, but there's two big things missing that I would want to add to make this much better. One is that none of this is being persisted. So I want to be storing this in a database so that every single time I create a new chat here, I can keep the code somewhere and I can go back and review a whole bunch of these chats. The other thing is that I can't iterate on this. We're not remembering what our previous messages were. So every single time I type a new message in here, it's just starting from scratch. So if we set up a database, we'll be able to load in existing messages before we run this. We'll be able to save a new message in this stream, and that will make this a much better and much more complete application. And I'm going to save all of that for my next video, where I show you how to use Terso with Drizzle to set up a database and persist data for this application. So make sure you're subscribed and don't miss that video.